we're going to start by identifying what values of x is the function increasing. At this point, I don't expect us to really have any idea what we're really looking for there. Okay, so when describing whether a graph increases or decreases, it's all about what are the y values doing and what are they doing as we move to the right. So if I start at the leftmost part of this graph, as I work my way to the right, I find that I'm going down here. Okay, these are my decreasing intervals. Okay, and those arrows I'm going to signal as the decreasing. Why don't I get another color so I can do it? Same thing with the increasing. Okay, so then we hit this point. We're going to come up with a name for that point in a second. And after we hit that point, now as I move right, now I'm going up. This is an increasing interval. And then again, we'll hit this kind of maximum point here. Now I'm going back down again as I work my way to the right until we get back down to this minimum. And then it's increasing until we get to this last point right there. Okay, and we'll consider this going to infinity over here, and we'll say that that graph stops there because it's not going to the very edge. Okay, so the arrows are kind of signaling whether we're increasing or decreasing gears. So the downwards arrows are decreasing values. The upwards arrows are the increasing values. Now, when describing where it is increasing or decreasing, we're describing the set of x values. So kind of like domain and range, we're going to use interval notation. Okay, so one thing I've done with this unit in the past where at the bottom here, we can kind of think about where we're increasing and decreasing. So we're decreasing all the way to the left of this graph until we get to this minimum point right here, okay, which is in between 0 and 1. So this kind of horizontal line is the interval for where we're decreasing. Then we're going to decrease again at this value until we get all the way over here to that minimum, and then we start to increase again. Okay? So now we need a way to describe these intervals. So this interval for where we're going down starts all the way left at negative infinity, and then it stops decreasing as soon as we get to this minimum point, which let's just call it 1/2. I don't know exactly what it is, but let's call it a half. Okay, or 0.5. Now, when describing the interval, we're going to always use curved brackets because at this point, at the 1/2, it's not doing either one, right? It's not decreasing or increasing. It's just kind of, right? It just switches there. Okay, so that just stays the same. Now, something new that we didn't talk about with interval notation earlier in the week is when we have multiple intervals, we need a way to group them together. So another symbol you're going to see is this letter U. That is the union. Why am I blank? Union? U-N-U-I-N? Oh, no. I-O-N. This still looks funny. Is that right? Okay. So union, which means including. Okay, so when you see that symbol, it means we're including another interval. Yeah, Phoenix, go on. Yeah. Let's just do this. Decreasing. Increasing. All right, good call. Okay, so those are decreasing. But now there's another interval that's decreasing, right? We decrease again when we're in between 1 and 2, so that's why we need that union symbol saying we're decreasing on the interval from negative infinity to 1/2 and or including the interval from, this looks like it's like 1.5, whereas a fraction that'd be 3/2. And then it stops decreasing once we get to this minimum value, which again, I don't know exactly where that's at. Let's call it like 2.8. Okay, I don't have a good fraction there. Let's keep it in fraction form. Let's call it fourths, so 4, 8. Let's call it 11/4. Okay, and again, when describing these intervals, you will always use the curved brackets. Okay, because at those exact values, it's not doing either. It's not increasing or decreasing. Okay. There are the decreasing values. We doing okay in this front group here? All right. A lot of chatter. That's fine. Let's save the chatter for when it's appropriate to have some conversation. All right. Now, increasing are just the other intervals here. Okay, so we're increasing here, going up from the interval at 1/2, and we start or stop at this 3/2. So we're increasing 1/2 all the way to 3/2. And then the union, so including the interval from this second value that we're calling 11/4, and then we're saying that it stops increasing at this point, which is at 3. Okay, so that's part of what we're going to look at today, is just describing the intervals where it's increasing or decreasing. And again, the key part of that is that it's the x values for where we're either increasing or decreasing. All right, then we're going to also identify on graphs any maximums that it has and any minimums. Okay, so does the function have a maximum? If so, what is the maximum value and where does it occur? So there's kind of two questions here. Where the maximum happens is the x coordinate and the maximum value is the y. Okay, so this graph, it's going all the way up to positive infinity. Okay, so there's really no limit to the maximum value we're going to get here. So we're going to see that there's no absolute maximum. Because it goes all the way to infinity. Okay, that's what this arrow is showing. But another term we're going to define here in a second is this point right here is considered a maximum within the kind of view that we're seeing of this graph. So this is considered a relative maximum. Okay, so if you're standing on top of a hill, right, we can picture that if we were standing here, right, we're at the very top of that hill, that's considered a relative maximum. Okay, so relative maximum at x equals, we call that value what, 3/2? And the max value is the y coordinate, which is 3.3. Okay, so there's going to be a difference between absolute maximums and minimums and relative maximums or minimums. Okay, the relative is just, is there any hill and any place where you could be standing on top of that hill? So then for the minimums, it's the exact opposite. Okay, so do we have any absolute minimums? Is there the lowest point on the graph? And there is, right? This kind of valley, so if we can get to the bottom of a valley, that's a relative minimum, but that is also the absolute minimum of our graph. Okay, so the absolute minimum is at x equals, we called that 11/4. And the minimum value is, let's call it negative 4.8. Yeah. Either one, it doesn't matter. Yeah, you can do either one. Okay, yeah, no preference there. All right, then there's another valley here. So this graph has another relative minimum, okay, at this valley point where we switch from decreasing to increasing. So there's another relative minimum at x equals 1/2, where the minimum value is 0. Okay, so the x coordinate is the location. The y coordinate is the actual maximum or minimum value. Okay. So like I said, a lot of really kind of small subtleties with these. Yeah. Yeah, that's what we stated, both of them. We stated that one as being the absolute minimum, And then we stated that one as just being the relative minimum because it's like a valley there. So yeah, it's both, right? It's the absolute minimum and a relative minimum. Okay, so it can kind of take on both there. All right, now let's just kind of clean up these definitions here, or just be a little more explicit with these definitions. So a function is increasing when, let's say, when the y, increasing when, as x gets bigger, so does y. Okay, so as we move to the right, that's what I mean by getting bigger. So as we move to the right, if the y values are going up, it's increasing. So as x is getting bigger, as x is increasing, the y values are also going up and also increasing. Okay, and then decreasing, just the opposite. So as x gets bigger, so as we move to the right again, now instead of us going up, now the y values are going down. So it's decreasing as x gets bigger and y gets smaller. Okay, or as x increases, y decreases. And as x increases, y increases. All right, go and flip this page over. All right, minimums and maximums. The absolute maximum is the largest or highest point of the graph. Okay, if it goes to infinity, then there is not a absolute maximum. Then the absolute minimum is the exact opposite. So that's the lowest point on the graph. And again, if it goes all the way down to negative infinity, then there aren't any relative or absolute minimums. And then the relative maximums and minimums are like those hills and valleys. So for the maximum, let's say it's a hill. And that hill is created by our function increasing and then decreasing. Okay, so let's make another note of that. It's where the function switches. So where we switch from increasing to decreasing. Okay, that's what creates that hill. So if you look back at that opener, you'll see that as we're moving to the right, we're going increasing, then we get to the top of the hill, and then we switch to decreasing. So this is a hill in quotation marks is what that's saying. It's where we switch from increasing to decreasing. And then the relative minimum is going to be just the opposite. So this is a valley. And that valley forms by us switching from decreasing to increasing. And again, if you look at that opener, you'll see that the two valley points we identified, we're doing exactly that. We're getting to that valley by decreasing, then we hit that valley point, then our function flips and starts to increase. Okay. Last thing I want to touch on here is actually coming back to the increasing and decreasing, intervals. So down here, when identifying increasing/decreasing intervals, we will always describe the interval as a set of x values. Okay, so the interval is a set of x values where the y values are either increasing or decreasing. So it's whatever the y's are doing that ultimately has this function increasing or decreasing. But the interval will always be the x values and just the x's. All right, and then when identifying the maximums and minimums, we will always use the x coordinate as the location. The y coordinate is the maximum or minimum value. I know it's a lot of notes. We'll work through one example here in a second, then I'll have you all work through the second one. I'm guessing we're going to run out of time, so that second one, that might be what we kind of come into class and do as our warm-up on tomorrow for. All right, but once you have this done, go ahead and flip the page. We're going to just skip. I don't want to go through this. We got a bunch of examples, so you can just skip that part. Okay. Expect this exact type of equation or type of question to show up on your quiz. Okay, where you identify all these different things that we've kind of talked about in this unit thus far, with the exception of the intercepts. Okay, but we'll talk about all this. So I like this. We're reviewing a lot of stuff here. So let's start by, if your graph goes to the edge of, or if the line goes to the edge of the graph, assume those are arrows. Okay, that's always something I can clarify when you're working on a quiz or a test or any homeworks. Okay, whether or not they are arrows or just endpoints. And let's describe the domain. Okay, domain is a set of x values here. So I'm noticing that this graph, even though the arrows are pointing up and down, they're still pointing left and right. Okay, so the domain is every single value here. This graph is going all the way left to negative infinity. Again, all the chatter needs to stop, please. Okay, it gets distracting. Hey, these arrows are pointing left and right, so every single value is included in the domain, and the range idea is the same. Okay, it's pointing straight down, straight up, meaning the graph extends in both those directions, and so the range extends from negative to positive infinity. Then for the increasing and decreasing intervals, I do think it's helpful to kind of draw those arrows that I was doing. Okay, where if I start on the left side, what is my graph doing? Well, on the left side, as I work my way to the right, I'm seeing that my pen is going up. So this is my increasing, 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 increasing until we get to that value. Then we switch. So now the y values are going down. So that's my decreasing. And then it finishes by this last interval continues to increase all the way to infinity. So I'll make sure I get this one right this time. The increasing is what I have in blue here. It's starting to increase all the way left. Okay, it's not necessarily the value we see, but it's dependent on what is going on at the end of the graph here. So it starts to increase right away at negative infinity. It stops increasing once we get to the x value that's at negative 2. And again, we always use the curved bracket there because at exactly negative 2, it's not doing either one. It's not increasing or decreasing. Yeah. Yeah. So, and for the decreasing, it starts to decrease at negative 2 or just barely past it. That's what that curved bracket is kind of telling us. That it starts to decrease at like negative 2.000001. Okay, so just barely after it. And it stops decreasing once we get to the x value of 0. So we're decreasing from the x values that span from -2 to 0. Yeah, it's this x value right here. Yeah. Okay, then we still have more increasing, so we're increasing from 0, and it increases basically for the rest of that graph there, so to positive infinity. So we increase from 0 to infinity. All right, now relative maximums and minimums. I see this hill right here, right? I'm switching from increasing to decreasing. So there's a relative maximum at x equals -2. The max value is 0. Okay, so again, with these relative maximums and minimums, the location is x. The value is the y coordinate. So the y coordinate here is 0. So that relative maximum, y is 0. And it happens at x equals -2. I'm not seeing any other hills there, so that's the only relative maximum. Yeah, good. Yeah. I don't know that I would count it wrong, but I want us getting used to kind of saying the location, so at x equals and then what the max or min value is. Okay, so not super picky there, but I would prefer that we just kind of write it out how I'm doing here. Right, then the relative minimum, that happens at x equals 0. So that's the valley there. And the minimum value is the y coordinate, which is at -4. All right, we're almost done here, and then we'll stop, at least in terms of me going over this. So last couple things here. Okay, the absolute maximums or minimums. It needs to be a specific value. Okay, it can't just be infinity. So in this case, there are none, and that's because graph goes to positive infinity. Okay, minimum, same thing, none, because the graph goes to negative infinity. Okay, so it has to be a place that we can reach for it to be a maximum or minimum. All right, and then the intercepts, hopefully that's nothing new, but that's just where the graph crosses each axis. Okay, so the x-intercept, I'm seeing two of them actually. I'm seeing an x-intercept at x equals -2. I'm seeing another one at x equals 1. So I'm just looking at the x-axis and where it crosses or touches. And then I'm seeing a y-intercept here at y equals -4. Okay, so the intercepts, you're just telling me where it crosses that particular axis. All right, the very last thing here, is this a function? Basically, this is asking, does it pass the vertical line test? Yeah. Something that a lot of us forgot about on the test. It passes. There's nowhere you can draw a vertical line and intersect more than once. So yes, it is a function. Every x value has one corresponding y. All right, so for the rest of class, I want you to work in your groups on this second problem in the notes here. It is a piecewise function, so it's going to be a little bit tricky. This is what we'll start class with on Wednesday, and then I'll give you the rest of the period to review. There is a homework assignment, so I'll give that to you all in case you want to start it. You also get some time in class on Wednesday.